This video will show how to get rolling with your PASCObot using Blockly coding. The PASCObot Sense and Control Kit is a highly engaging tool that helps students learn how to create code that interacts with the real world. Students can program the PASCObot to execute precise motions that respond to inputs from its sensors. The brain of the PASCObot is the included control.Node. It also provides power with its rechargeable battery. The control.Node has a built-in 3-axis accelerometer and a speaker. The kit comes with a rangefinder that measures the distance to objects up to 1 meter away and a line follower that uses reflected infrared light to navigate a line course. Students can command the PASCObot to manipulate its environment by programming the 2 servo motors connected to the included gripper. Also in the box are multicolored cups that are perfect for testing gripper code and black and white line follower tape so any color surface can be used. The minimal amount of assembly required is made easier with the included screwdriver that has a magnetic tip. The sequence of activities for the PASCObot Sense and Control Kit progressively builds student knowledge and coding skills. Let's go through the first activity to show how the Blockly coding tool in SparkView software makes it easy to experience success quickly. In this activity, students create code that commands the PASCObot to move specified distances, turn, and pause. First, turn on the control.Node by pressing the button on the bottom. The red light flashing on the top indicates it's ready to connect to your computing device by Bluetooth. It's a good idea to place the PASCObot on its end to prevent unexpected motion. Next, start SparkView and select sensor data. The control.Node shows up in the list of devices. Click on the one that corresponds to the 6-digit ID on the top of the control.Node. Next, select what measurements you would like to display. If you're unsure, no worries, you can always add them later. Let's select position and velocity port B and unselect everything else. Port B is connected to the high-speed servo motors that drive the left wheel. It will show positive values when the PASCObot is moving forward. Distance shows up as an option because I have the rangefinder installed. Next, we pick the display we want to start with. You can add other displays later too. Let's pick the graph display. That brings up 2 graphs, position and velocity, both on the same time axis. To get the PASCObot moving, you need to write some code first. Clicking on the code tool toggles to the coding window. Advanced users can control the PASCObot's high-speed stepper motors using this block in the hardware menu. Instead, let's load a function from the PASCO library by clicking on the import code tool. A list of functions available for the PASCObot is displayed. A short description will display after selecting them. Let's select Move a Distance and click OK. The function block to move a distance appears. Move it off to the side, being careful not to delete it. The other block calls this function. It can be deleted because you can always drag another from the functions menu. Then add a number block from the math menu. Compatible blocks will stick together like this. Let's write a program that moves the PASCObot 50 centimeters forward and 50 centimeters back. The note block tells us that a negative value will move the PASCObot backwards. We can combine the 2 blocks and enter 50 and negative 50. Let's toggle to the display window and click Start to execute the code. Look at the motion graphs displayed in real time. Students using the PASCObot can learn math and physics while they learn to code. Let's go back to the code window and import the turn functions. Two separate functions appear, turn right and turn left. Drag those out of the way. And we can use the call function blocks to command the PASCObot to make 90-degree turns. Given the size limitations of this table, let's program it to move clockwise in a rectangle. We won't be turning left, so I need to delete or disable the call left turn block. Right-clicking on any block brings up these options and more. The duplicate option is very helpful. Let's use it to make more turn right and move a distance blocks. Alternatively, I could drag more from the functions menu. We can click Start once we're ready to test our code. I recommend using the PASCObot on the floor so a mistyped entry or errant code block doesn't send the PASCObot over the edge. Students now have the skills to create code to navigate their own PASCObot courses. They can add pauses using the sleep block in the time menu. They can add sounds using one of the control.Node speaker blocks in the hardware menu. They can use loop and list blocks to make it easy to command any number of motions and turns. The student activity has samples of working code to help them. Students will want to explore the working of the other functions in the PASCO library. They'll want to see how the accelerometer can detect obstacles and inclines. Students will be eager to see what the rangefinder, line follower, and gripper can do. They'll want to incorporate other PASCO sensors, including the code node that is designed to ride along in the PASCObot. The biggest problem you'll have is getting them to go to their next class after the bell rings. More information about the PASCObot Sense and Control Kit can be found on the PASCO website. Help for Blockly coding can be accessed from the SparkView Help menu and the PASCO website as well. Student activities are posted in the PASCO Experiment Library. Thanks for watching.